In this lecture, let us talk about commercial FM transmission using Armstrong method. So, the idea of converting a narrowband FM to a wideband FM was basically due to Armstrong. So let us look at a commercial FM transmitter using Armstrong method. To start the discussion, let us say we fix our requirement, and that will also give us some idea as to what are the typical values that we used in commercial FM transmission. As I said, the frequency range of your FM transmission is 88 to 108 megahertz. So totally 20 megahertz. Okay, so let us say we want a carrier of 91.2 megahertz. So my FM channel is operating with the carrier frequency of 91.2 megahertz, and typical frequency deviations that we are looking for in an FM signal which is commercially being used for broadcast purpose is of the order of 75 kilohertz. This is a typical value that one should remember. Maximum frequency deviation is 75 kilohertz. It is more or less a standard value. Okay, almost we'll use this value. Okay, now so these are the given specifications. Now this represents what type of frequency modulation? A wideband modulation, because the frequency deviation is very high, 75 kilohertz. Now how do you decide whether the frequency deviation that you corresponds to a narrowband FM or wideband FM? See, you should compare it with a large frequency component present in the modulating signal. Okay, so how is beta defined? We said beta is equal to delta F divided by FM, right? Or your beta or deviation ratio, that is defined by delta F divided by W. What is W? W is the bandwidth of your modulating signal. Bandwidth of modulating signal. Okay, let's say we are talking about music. What is the typical value of W? It is about 15 kilohertz, because each instrument produces different frequency component. Therefore, in this case, your beta or D is equal to delta F is 75 kilohertz divided by this is 15 kilohertz. So roughly it is 5 or more. So definitely this value is not a narrowband FM. As I said, narrowband FM beta value is much less than 1. Here beta is 5. So therefore this is not a wideband FM, but this is a wideband FM and not a narrowband FM. Okay, so therefore this value indicates that we are talking about wideband FM. So now how do you generate this wideband FM from a narrowband FM? That is a question that is in front of us. So if you want to generate using the indirect method, in the beginning itself I can't generate 75 kilohertz of frequency deviation. So let me start with a very small value of beta, and then slowly using frequency multiplier I can get the beta value of 5. So I must choose a value of delta F1, delta suffix F1, which produces beta which is less than 1. Okay, so choose delta F1 such that your beta is much less than 1. Now my message signal, which is music, it is a range of frequency, right? So this range of frequency is, let's say it starts from 50 hertz and it goes all the way up to 15,000 hertz. let us say the modulating signal that we have will be typically like a speech, audio or music. So the typical spectra of this range from 50 hertz in the lower end and 15,000 hertz in the upper end. So keeping that in mind, now which value should I choose? Either I can calculate 50 hertz, I mean maximum frequency deviation del f is equal to, as I said, I'm sorry, beta is equal to del f by fm. Now in this case del f is given 75 kilohertz. Now should I choose 50 hertz or 15,000 hertz? So that is a question. Okay, keeping that in mind, which one should I choose? Let me say beta 1 is equal to delta f by fm, which is 75 divided by 50, or beta 2 is, because highest frequency is 75 divided by 15,000, this is 5, and this one is huge, roughly around 3,000. Okay, so should I consider 50 hertz or 3000 hertz? Sorry, 15,000 hertz. One second. Okay, it has come. Sign in. Suddenly it is giving a problem.